do is
We didn't get the last part, I think, but the last 10 seconds звук. Or...
So sorry, I was just, I think I lost connection. So what I wanted to say, bottom line, the feedback and the discussion with the working group 1 is more relevant for us than let's say high level presentation in TSC. So I'm going to go in the background because I'm bringing a lot of noise and I'm going to listen in carefully. Thank you very much.
Okay, and I would propose to have some questions after the demo or during the demo, just to have things more interactive, and then go to the next steps, HBR 2.0 with Chris. Is it fine? So, Chris, do you want me to share the slides from the TSC in December?
I have them as well, but someone would need to make me a presenter.
Okay.
So if someone is so kind and set me as a presenter in Teams, then I can share the slides.
I've done it.
You. Yeah, the first one I'll basically just skip because that's just the intro slide. Okay, so what do we have in terms of HBR? Why did we start all of this journey, and why do we think it's a perfect solution for the use case and problem space we have? So the main benefits is we have servers that are either, for example, in a free mode, they don't have any cluster on them, or servers that belong to a certain cluster. And as you all know, we have quite a complex networking requirements in telco, so connecting to a lot of VRFs, networks, connecting to all the legacy systems, interconnecting with also interconnection partners, and so on. So there's a lot of connectivity needs going on inside a Kubernetes cluster that hosts CNFs. And we needed to think, like, how do we make that as efficient as possible in our case, but also for our, other deployments as well. Because especially in our case, we are looking at bare metal deployments in sites that have hundreds or thousands of bare metal servers actually in them. And we need to make it as efficient and even not touching the network fabric as often to reduce any impact on other services and so on. So that's why we have HBR in here. And the main benefits is really this efficiency in dynamic environments where servers can belong to one cluster today and another cluster tomorrow. We also don't, as mentioned, need to touch the fabric anymore in most of the cases. So we can leave the fabric zero touch. Vlad can later share that he has never touched the fabric during the POC, except from the very early beginning. We also have security integrated into it. It decouples the network fabric configuration from all of the configuration that you need. And you also have the management, the GitOps, the Kubernetes native management of all the connectivity and resources you need to have to describe your connectivity needs. Okay, so why have we done this? Why are we sharing this with Silva is quite, of course, we think this is not only a solution for DT, but also a solution for others. So we began talks in TSC, in the Silva TSC in May last year, to do a proof of concept, to carry out that proof of concept, and then afterwards also consider an adoption of this HBR concept in Silva. So we've done the preparation, of course. We've also done the proof of concept. And we are now considering the adoption. And part of this is, of course, also this presentation in this working group 1. And what have we done? we have the collaborative setup. We have our side collaborating and giving the concept and consulting. We have Sixwind, who is offering or was offering the VSR as kind of the HBR router that sits on the host. Orange validating all that in the validation center in Paris. And all of that really came together really, really nicely with the people that we have on board from Orange, Sixwind, as well as from the collaboration from our side. So really had an amazing team to do this proof of concept and present the results here. Looking at what we've done from a phase perspective, we were only looking at the host of at this router that sits on the systems. So we're only looking at the VSR, using this VSR with configuration that was manually done, and not yet, we did not look into any automation aspects of it. Of course, what we have internally at DT is like we have the automation. We do that currently with our open source software here. Also, the network operator that we use is open source. You could look at it. But this was not part of the proof of concept for now. This is something that we will discuss when we bring all of this kind of together into Silver and work on it together. And it's kind of our proposal in the end anyway. Yeah. So we've done that proof of concept, as mentioned. It was quite a bit of a time to get the validation center ready because there were some licenses that needed to be procured, some preconditions to be met. But then in October and November, all the tests were performed. We had like the final report. We had the presentation in December to TSC. I think it's also recorded if you want to rewatch that. But it is mostly the same as today. And one of the deep dives is today in this working group 1. And we are at the end, of course, ready to discuss all the next steps. So I think I will hand over to Vlad for this slide here.
Yes,
he can explain it a lot better than I.
Okay, so maybe I can go into the demo first and then present the conclusions.
That's
just
good.
Yeah, so I will share my screen. Just one moment. Okay. So we have, unfortunately, we don't have a live platform right now on which to present the VSR and the host-based router. So for this POC, we had the Silva Validation Center platform in France, and we have, let's say, a limited platform when compared to a production, let's say, great platform, and it only consisted of two leaves, let's say, EVPN VXLAN leaves, which are connected, which are peering with a VSR on each node. And on each VSR, we created resources like Multus network attachment definitions. We forwarded the Calico traffic, and we did all sorts of tests. But just to give you maybe a better technical understanding of what's going on. So I want to show you a diagram with a potential EVPN VXLAN fabric, which is also extended to another data center with DCI, data center interconnect, and with a, let's say, legacy way to, without the host-based router, to use, for example, Multus. Can you repeat, or there was a question, or? It was, yeah, with the legacy mode to connect pod via Multus two EVPN VXLAN leaves. So we have different VLANs with Anycast gateways on the leaves with different VRFs, and these are also propagated inside the MPLS layer 3 VPN and also to remote data centers, to remote destinations. And so this is, let's say, the standard way to implement this in a EVPN VXLAN fabric, but without the HBR implementation. So what DT did, they extended, as you can see here, they extended the EVPN VXLAN the zone to each node, to each Kubernetes node. So in this new design, the Anycast gateways, the VRFs, and the networks are all, let's say, ending on the host-based router itself, including the infrastructure networks. And you will not need to configure the leaves anymore. So the leaves, the spines, will only carry encapsulated traffic, including interconnecting one data center to another. And so this is what's happening on the EVPN VXLAN fabric. So if you have any question or any observation, please feel free to ask. And if we want to look inside the Kubernetes node for this purpose, so we have the design, the default design for Silva, in which we have pods connected with the primary interface with Calico, with the VXLAN between the nodes for pod-to-pod communication. And we have also Multus, MACVLAN network attachment definitions, which are handled in a classic way by using the interfaces on the nodes. So we have the master interfaces, sub-interface with VLAN 100 on the node, and for this to work, we need to propagate these VLANs on the underlay, on the switches, and also declare the interfaces, I don't know, on the DC gateways or on the EVPN VXLAN, as I showed before. So it really consumes a lot of time, and it's a static work to configure all the VLANs on the switch and on the routers. But the evolution to HBR will mean that everything will be created in a, let's say, logical matter on the node. So we have the host-based router here, which will create a new namespace, the host-based router namespace, and will have a virtual Ethernet interface between the root network namespace and the host-based router namespace. And on this virtual Ethernet interface, we'll have the master sub-interfaces for the network attachment definitions. And this way we can have on the host-based router, on the VSR in this case, we can have bridging use case for VLAN 100, for example, from pod to pod. We can have routing use case in the same layer 3 VRF. So we can have all sorts of topologies only based on the configuration which is pushed on the VSR, on the 6-WIN VSR in this case, or on another type of router. And the underlay will simply not care about this traffic. And so, any questions till now for this evolution? Okay, then we can go ahead. So, in order to achieve this evolution, so for our testbed, we had the six servers connected in two leaves, and we activated EVPN VXLAN on each. These are Juniper QFX switches, and we created the BGP for advertising the VTEP IPs, and also BGP for advertising the EVPN family prefixes. And this was done by using a Helm chart. So we are creating the VSR pods on each node as a daemon set. So we'll have one VSR per node with each VSR with a running config of its own, which will actually peer with the switches and create the needed underlay and the BGP configuration. So if we want to go in some details of the actual BGP configuration, so this is actually the one. So we have the two QFX with the internal, with BGP, internal BGP for EVPN and external BGP for the underlay. And this is done in the beginning. So there is a configuration applied on the QFX switches, and then everything is stable. We don't touch it till the end. So now for the demo, for you to see how it's actually created. So we have this part. Okay. So the creation of the VSR daemon set is done by using a Helm chart. So it's actually only using this templating. I have a YAML file, and based on the values here, I am generating a config map, which is pushing the initial config of each VSR. So I can show it to you live here. So we have the values, we have the MTU, we have the IPs on each of the loopbacks on each QFX switch. We have the IS numbers used. We have all different, the version for the VSR. For each node, we have a loopback IP that is used for peering, for internal BGP peering for EVPN. And also we have in this YAML file, we have the VRFs with route targets, and also the interfaces with VLANs ID and with the corresponding VRF. And then by using this, let's say, template, we will generate and push the configuration on each VSR, which is created on each node. And let's say the beauty here is that by pushing this configuration, the VSR is creating all of these resources inside the node without us having to create, to SSH on the node or to create anything else statically. So all of this is created, the new namespace, moving some physical interfaces from the root network namespace to the HBR network namespace. This is done only by this configuration. So I will show you how this was done. So this is the template with the daemon set and with different init configurations. This is the YAML file. So we have here the two switches, the two QFX switches on which we don't have any BGP sessions active. And then with Helm installed, we are we are deploying the VSR on each node, and then we can see them created here. And we should have, as you can see here, so we have the underlay BGP session based on IPv6 and unnumbered peering, and also the BGP sessions with EVPN family with the loopbacks, which are established in under 2 minutes. Okay, so all of this topology is created with this Helm. This is not let's say the official 6WIND. It's not something that 6WIND is recommending or using, or this is not used by DT. It was done for this POC. And then after the VSR is created, we can see the BGP sessions also on the VSR. And then we have, this is the test topology. So we have pods with Multus and with Calico as well. And we are starting some pods with Multus, with some VLANs 100, I think, and some other. And we are starting some traffic. And here on the VSR, we can see the encapsulated traffic with VXLAN. So when we ping the other, when we ping another pod on another node, we can see on the secondary fabric interface, we can see the encapsulated traffic, ICMP traffic. So this is one use case that we tested for Multus. And the other use case that we had was testing, as you can see, the Calico traffic. So pods are having the primary interface is done by using Calico CNI, and we are also routing all of this traffic between nodes through the host-based router, through the 16 VSR. So also we are able to test this and capture the traffic to demonstrate that this is flowing here. So this is the primary, IP pool of Calico, and we have also the traffic flowing. Okay. So do you have any questions? Please don't hesitate to ask any question that will help you better understand the concept of HBR, or any other question.
Maybe Vlad, I just jump in briefly, because we promised to stay in a frame of 30 plus minutes. When you listen to this, and I appreciate that not everybody here in the round is deep in the networking. Might be that I'm mistaken, but usually Kubernetes platform people know about networking a bit, some more, some less. But here we see quite a lot of decent modern networking magic. However, at the end, this is showing the implementation details. When that's properly implemented, this first completely separates Kubernetes cluster and makes you independent from the network. And secondly, it's completely abstracted. So all these details are functioning, plus with automation, so that it brings to the Kubernetes for the telco use cases, so for the CNFs, amazing flexibility to configure any connectivity, any complex connectivity, while not involving the network team. That's one of the benefits. There are more. So if you look at this as it's a very complex, yes, there is some magic inside, but implementation of it and realization actually makes it less complex for everybody to use the Kubernetes and telco cloud in our realistic environment.
Yeah, the complexity is coming for the first step, and for bringing everything up, this let's say this underlaying and the BGP session and everything. But afterwards, by using the custom resources and the automation, it's quite easy. There was a question, please.
Yeah, so I saw that in the beginning you mentioned dependency on the Cilium. Is that right?
Dependency on Cilium?
On the Cilium. Is there such a dependency?
Cilium? No. Cilium,
no.
You mentioned the CNI. You mean the CNI, Cilium CNI?
Yeah, I suppose that's for the fast packet processing. So I guess maybe I heard it wrong.
No.
It's
not linked to.
Okay.
So we in our POC we've used the Silva default CNI, which is Calico open source. So
Okay.
we didn't use Cilium for this it was not
So
tested.
basically, there is no data plane packets acceleration.
No,
for this
no,
one.
no.
Okay, good.
For
Thanks.
this POC, we didn't use
Okay.
any acceleration. Okay, so if we don't have more questions, so please don't hesitate. We can present the use cases that we tested more. Yeah. So we analyzed the use cases that we have for our CNFs in Orange, and we wanted to evaluate the host-based router, mainly against features that are not already covered by the CNIs. So they are not covered by Calico, because the host-based router is not meant to replace the primary CNI. So the features like network policies, like service exposure, and I know even BGP for Calico they're not meant to be replaced by the host-based router. And then we wanted to see extra features which are not covered in the Kubernetes networking, let's say, world. So we wanted to test this Multus Mag VLAN network attachment. So moving the gateways from the physical network inside the nodes, inside the host-based router, to be able to leverage the automation possible for this. So this is one use case that I shown. So it's Multus Mag VLAN. And also what else we wanted to see was a potential egress solution. So to have SNAT egress for the Kubernetes cluster. So SNAT performed on the HBR. So not leveraging the SNAT done on every node, the default Calico open source, but using some more complex configuration and design on the VSR to perform this SNAT. And also this was successful. So we have, let's say, a working setup, not fully automated, of course, and it's not, we don't have CRDs for this, but it's some design that could work. And also we wanted to see the network policies, let's say, on Multus interfaces. So it's ACLs on Multus Mag VLAN interfaces, which is also a use case which is not covered in Kubernetes. There are some options that, So also we did this test and it was successful. So the VSR is able to filter traffic coming from.
But Vlad, the feature that you are mentioning about the capabilities of VSR is out of the scope of what we can support in Silva. In Silva, we won't rely on VSR features. So.
Yeah, the VSR could do this, but when it's not decided to use it in the end for now, but still
I'm not even sure we will be able to use it in the context of Silva because it's not an open source component.
Yes, you're right. So, but with the VSR, it could work. More features could be added.
Sure.
But
the way to use those features is by leveraging an API that would let us use the underlying features with a kind of standard API. This is what you are working on with the network operator.
Exactly. So that's what I wanted to just jump in on that remark, because yes, probably using VSR in Silva might not be an option because it's a closed source product in the end that usually, of course, you have to pay the licenses for and so on. Of course, telcos then at the end might choose, for example, VSR or any competitive product that supports it, because they might want to have support or anything else. But I'll just grab the screen share again and wrap up on the network operator architecture. So on the left side, you can see basically the network operator that we have today. We have 2 Kubernetes custom resources that are called VRF route configurations, describing this connectivity to a set of VRFs, as well as the layer 2 network configuration, describing then layer 2 networks that can be consumed by Multus MacVLAN, for example. This host network operator then goes, looks at them, of course, does a standard reconciliation as you have in Kubernetes, and then talks to the Linux kernel, creates the necessary interfaces, and also talks to a small component called FRR, which is the routing daemon used in our case. And FRR, you might know it nowadays also from MetLB because they use it as well internally, is a routing daemon that is completely open source. It is out there on GitHub. You can contribute to it, and it has quite a large community. And even the 6WIN VSR is internally based on FRR. So you have a lot of users from 6WIN to all of the Sonic ecosystem is also using FRR, for example, as the routing daemon. So it is an active community, for example. But we were, of course, very opinionated with the host network operator that we designed in the first step, which was only talking directly to Linux and also directly to FRR. And our evolution to the HBR and to the network operator is a decoupled concept, having APIs that describe what you actually want to do. For example, I want to have a VLAN, I want to have a VRF, I want to connect to this, I want to have BGP peering, and so on. And then the host network operator translating that into a configuration for each node. And that configuration can be consumed by an operator or controller, which is specifically designed to just talk to a specific implementation of a routing daemon or of a host-based networking stack. For example, that might be a CFRR, which is FRR packaged into container, which is one of the things we will deliver end of this month or end of this week, and is the reference implementation for a routing daemon that supports most of the features that are that we've tested in the previous proof of concept. But also vendors can choose to implement the APIs and then talking to their own routing stack and configure their own routing stack to be able to be used as a host-based router in that case. Of course, there's also a small component that needs to talk to the Linux kernel or to netplan, nmstate, or whatever, to also create some interfaces on the host if you need them, but that will also be in scope. Another nice thing you can do with that is you don't need a host-based routing stack to use the new host network operator. At least that's the target. Because the goal is that you can go ahead and say, I want to have a VLAN on the Kubernetes cluster, and then it sees, or then either it has host-based routing installed and it will configure this VLAN on the host-based routing stack, and you don't have to do anything on the fabric, or it will just be a layer 2 VLAN that sits on a port going to your traditional switching infrastructure, but from an integration perspective, so from a telco perspective, integrating that, it will be the same. It doesn't matter if it's the layer 2 to the fabric or if it's host-based routing in that case. Of course, you get all the nice features with host-based routing on the host and so on. But in general, the API would kind of be the same in the end. So what we, of course, also want to do at some point is we want to, and we are very open to do that, to deliver this host-based routing also to Silva. and we will release the HBR 2.0 as a pre-release, also with the reference implementation, as mentioned before, end of this week or end of this month, depending on a bit of the timing. And we, of course, will keep you informed about everything around that. Of course, we also want to kind of propose all of this host-based routing to be a dedicated working group inside Silva, so we can work especially on this API side here and can standardize that to have a common layer, because what we will release at the end of this month will only contain this layer down here and not the northbound APIs for now. And there is, and we also want to do some testing, of course, of the HBR 2.0 in the same fashion we've done with the VSR, and some comparison with some Orange project called Virtual Network Attachments. And in general, we are very open to deliver to donate this HBR elements and also the software to Silva, but we still need to kind of do the legal evaluation and approval and all of that for that, because currently it's under DT organization and owned by DT and so on. Technically, it's open source, but still we need to do the discussion. And yeah, this is kind of the wrap up from the from my side on what the future is regarding the network operator and regarding host-based routing for us as well as for Silva. And yeah, then we are open for any questions that may arise now.
Probably
so Chris,
one. Go on.
So Chris, you just mentioned that you will have southbound interface to support NAM state type of configuration.
That's an idea. So we have, of course, we are looking at which operators are already there, like from a network operator perspective that configure the host. I think the only operator that makes sense and is present and well known also inside the industry is the NM state operator.
Yeah.
And if we want to support, for example, layer 2 features, it might be an idea to use this operator to configure the layer 2 use cases on the host. So cases without any HBN or HBR in use, because it's well known, well supported. It has an ecosystem. I also know one of the maintainers and so on. So yeah.
So have you guys done any POC work for the HBR 2.0 yet, or is all this work, the current work you did with Silva is on 1.0 only?
So the work with Silva was mostly actually without any network operator at all. So we've in the demo, Vlad has shown mostly manual configuration without any network operator involvement. We have the network operator 1.0 in production today in DT. It's the same version that you can find on the GitHub. So there are no kind of internal changes to it. And also HBR 2.0 is currently in development. It's not just existing on the slide. So we have already this containerized FRR. We already have the network operator to configure it. I'm just fighting with small, tiny bits to integrate them at the end this week. And then we can hopefully give that to the community. But for example, what is also open source already is the southbound API towards the HBN module. That is also already in the repository. It's in a different branch, for example, but it is already there.
I see. So that's the 1.0 HBR POC you guys done so far. Did you guys like try the different distros, the Linux distros? or it's pretty much all based on Ubuntu type of verification?
It's only
Silver Lab
Ubuntu.
was,
It's only Ubuntu,
exactly.
yeah.
Silver Lab was Ubuntu. We also only use Ubuntu, but I'm actually open to test something else. Like you're probably looking for Red Hat, yeah.
Yeah.
Yeah, I can jump in here. So definitely there are two layers of it. One is just purely testing on a available Red Hat-based infrastructure or Red Hat OS-based infrastructure. So that something could be done independently. The second layer is more engagement and exchange and cooperation with Red Hat on this concept. And this is something we are moving on in the background a little bit, trying to connect with the right people, and there will be some session on that with relevant Red Hat people beginning of February, independently of these activities, because that's the concept that Red Hat also in another shape and form is contemplating, as far as I understood, in the networking related units. And this is the second aspect, whether we are able to join forces there, not only to make it run on a Red Hat OS, but also to jointly contribute, maybe do some adoption and stuff like that.
Yeah, that's precisely what I'm kind of trying to suggesting, because I did invite Frank Bodin from our sides, who actually is working on the on the project in parallel. Frank, do you want to share something here and maybe hook up with because we do want to have a consolidated unified project, I think, for Silva, because it has been pain in the butt in the past where different upstream project works, like Silva is trying to have a single consolidated project which for different distros, right? So Frank?
Yeah, so we have a complete solution from a elements perspective, but from a feature set perspective, it's pretty limited. But we have a PE router which is running on Red Hat OpenShift, and that can run on any Kubernetes distribution. And one of our lead developer is going to present it at FOSDEM, so next week. And the stack will look exactly the same. So EVPN route type 5 with even Calico running on top. So this is something.
Federico, Frank?
Federico, yes, Federico Paulinelli
okay.
will be there.
Okay. Yeah. I'm usually in chat with him, so yeah, I know quite a lot.
Yeah, so he has a session at FOSDEM. So after FOSDEM, I believe there will be a recording. The slides will be available. So if you have questions, that would be nice. If you have feedback, and as usual with Red Hat, it's 100% upstream and open source.
But then, Christopher, what is the overlap? If you already discussed with Red Hat, is there an overlap between the two projects, or?
Currently not.
No, there is only. I mean, I can also in this round share. So Ram Polak, who is also part of Silva, is discussing this with a product or business unit in terms of potential synergy there. Of course, what Federico is doing, and then we also know from the Metal LB discussions, this is definitely also interesting to that, but this is more rather now strategic exploration, so to say, to see whether we could find synergy there, and if Red Hat would join, let's say, this activity, not having another parallel or equivalent activity. So this is what's going on. There is no lab, no POC plan. But Chris, a couple of colleagues, so I think Max, Marcel, and then Jens are going to host them.
Yes.
Next week, maybe you can leave the note to Marcel to connect to Federico. And
I already left the note to Federico that Marcel is going because he asked me if I'm going.
Okay, vice versa. Yeah. Okay, good.
Yeah.
But then Marcel is aware of this P router.
Yep.
Option. Okay. So the question, Frank, is why not trying unifying? But that would probably require understanding the approach that Red Hat is following, and then see if this is just another CRA that might be available as an option, and then having it plugged into concept so that we have more choice in the CRA branch, or it's like a fully vertical integrated solution, which is doing similar things but in a bit different way.
It's going to be fully integrated into Red Hat OpenShift in a way that will permit third-party integration. So it's and also all of the elements, in particular the PE router, is totally standalone. So it can be integrated as a component. So you can pick and choose whatever you want. So you can have a look at and Federico is not going to demonstrate necessarily so he has to so he has two demonstrations. One is on Red Hat OpenShift and one is on I would say upstream. It's on what the name? It's the container lab. Okay.
A container lab.
Yes. So I mean, yeah. Let's. I mean, I think the vertical integration is it's too early to really focus on that. So we can focus on the elements, the upstream elements, and decide. You can decide within the Silva project what could be the reference implementation, the 100% open source reference implementation, with options to swap out some components and to have some proprietary, more powerful, more featureful components at strategic places of the stack, like 6-wind VSR, like other components. So yeah, it's a very modular approach that we are having. But of course, in our testing, we test only with open source and upstream components.
That's very similar idea. Maybe it goes beyond this round, but exactly in that way it's meant to have a central open source upstream standard for management and automation of this host-based routing or host-based networking setup, and then pluggable modules for the CRAs, for example, for a reason of features or for a reason of commercial enterprise support possibility. And if the companies build products on top of that vertically, that's also part of the idea. But let's explore that. I'm expecting also Ran to come back with some more details, and we can see that's parallel thing to simply installing it on a Red Hat enterprise Linux and running it in that way.
Yes, Vok, we will have something to discuss with you. Hopefully, later on, we are trying to set up the relevance for mid-February, as mentioned on the communication. So stay tuned. I will let you know, of course, for the final for that one.
And for Silva plus HBR, the work you've done so far, what are the next steps from your point of view? Do you still have topic to explore? Do we wait for the network operator version 2.0 to be available to consider a packaging in terms of Silva units? To work on this packaging with the Silva community?
So what we, in short, would like to do, we leave it a bit open as the things are developing fast. So first thing is that could be, we didn't discuss yet in the working group all details, but what we would like to achieve is till March timeframe, potentially April, have the codes in the shape to be like used and to be donated. Short term, there will be a FRR based CRA available. Maybe that's one of the things that could be tested as an alternative approach to upstream based approach to FRR or to VSR. And then the network operator in its initial beta alpha version will be available. So this is also something that we hope we will be able to test. It was meant to be a phase 2 of the POC, but we are now running in parallel fork stream establishment on one side and potentially doing further setups for the testing, like with network operator or with FRR CRA. And then when these things are true, of course, the network operator is there. The test Silva unit could be established for a checking how it runs in a Silva cluster. But I'm not sure if we are going to reach the point to contribute to donate the codes from this legal licensing perspective. So it might, we have no yet ideas if it's going to take long or short. We hope not that long. But as Chris said, this week, latest next week, the branches will be published or pushed upstream into telecom projects. And these come two parts, CRA, FRR, and network operator. Very first version will be visible and usable, and then we take it from there.
Okay, great.
I would probably wait before making a Silva unit and then putting effort. I would probably do the test with the manual installation, like independently on the ready cluster, and then.
So, Vuk, Chris, you think we could test this in February with some manual setup, of course, but you think it's feasible to only test some setup?
Yeah.
Okay.
Maybe end of February. You also need to check internal priorities, but it should be doable.
Okay.
Yep. And there is this open topic which we agreed to start addressing is what if you don't have a fabric that's according to the blueprint which Vlad has shown, like EVPN fabric, but just a normal L2 fabric. The network operator, I don't know, Chris probably didn't emphasize that, but or at least I didn't notice it. The network operator is capable or will be capable to support limited number of layer 2 cases, like for when you have a just standard traditional network setup, it will be able to run certain automation as well and configure the node to avoid the manual interventions. So it might be already usable as a kind of component without network fabric. But these things are something that we would rather do when we establish a working group and then donate, so that it's a community approach. And for that, we would need to stay in a close touch with the working group 1.
Okay.
We stole your entire time for today. Sorry for that.
No problem. I wasn't having any specific topic for today. Maybe if some of you have some, we can dedicate a few minutes about them. Don't have any other topic for today? Okay. Thank you, Vlad. Thank you, Christopher and Vuk also for this very nice demo. We will definitely keep in touch with you to keep testing what you are delivering. So you plan to create a dedicated working group in Silva, or the working group you mentioned is?
Yes, the networking working group to deliver, to be a home for these developments and artifacts that can be then consumed in the stack. So this is the idea currently that we are preparing for.
Okay.
Thanks once again for the opportunity, and hope it's just the first one in a series of future exchanges.
Thank you all for attending. Thank you for the presentation, and see you next week then.
Thank you for the presentation. Thank you.
Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.
Bye.
Thank you. Bye. Thank you. Bye.